Good morning, friend. I'm Dr. Santosh Chalil. I'm from PhD, Department of Pharmaceutical Chemistry, Mates Institute of Pharmacy. I welcome you all for seminar of my student, Mr. Rahul Asole. Over to
Thank
you,
you,
sir.
sir. Yes, sir. I'll share my screen and I'll continue, sir. So hope everyone can see my screen. Hello everyone, good morning. My name is Rahul Kiran Asole. I'm from third year B Pharmacy from MET's Institute of Pharmacy, Bhujbal Knowledge City. Today I'm going to discuss about the anti-hyperlipidemic drugs. So what exactly is hyperlipidemia? The lipids of human plasma are transported into the macromolecular complex, and these macromolecular complex are termed as lipoproteins. There are a number of metabolic disorders that involves the elevation of any lipoprotein series, and these are termed as hyperlipoproteinemias or hyperlipidemias. So hyperlipidemia. There are two major sequelae of hyperlipoproteinemia, which are acute pancreatitis, and the second one is atherosclerosis. There are lipoproteins which contains the alipoproteins, and these alipoproteins are also called as apoproteins. So the pharmacological agents which reduces the concentration of plasma lipid are termed as hypocholesterolemic agents. Increase in the plasma lipid levels, particularly the cholesterol, is common feature of atherosclerosis. Atherosclerosis is a condition which involves the arterial damage. This arterial damage may lead to the ischemic heart disease, sometimes the myocardial infarction, and it may also lead to the cerebrovascular accidents. Now, increase in the plasma concentration of these substances is called as hyperlipidemia. Now, this is the structure of lipoprotein. The lipoprotein, as you can see, this is the core structure which is surrounded by the monolayer. We'll see these subunits. The lipoprotein, which is made up of two subunits. The center core, which is of hydrophobic lipids. These hydrophobic lipids, as we can see, is made up of triglycerides and cholesterol esters, and the outer monolayer which surrounds the hydrophobic core is made up of hydrophilic coat of polar substances. These polar substances are phospholipids, free cholesterol, and apoproteins. Now, lipoproteins are the macromolecules consisting of the lipid substances. These lipid substances is of core, which are cholesterol and triglycerides, which are non-covalently bound with protein and carbohydrates. These combinations solubilize the lipids and prevent them from forming the insoluble segregates in the plasma. They have the spherical shape, as we have seen earlier. They are having the spherical shape, and which consists of non-polar core surrounded by a monolayer of phospholipids whose polar groups are oriented towards the lipid phase of plasma. Now, included in the phospholipid monolayer, that is hydrophilic outer monolayer, there are small number of cholesterol molecules and proteins. These are known as alipoproteins. These alipoproteins appear to be able to solubilize lipid for transport in aqueous surrounding such as plasma. Now, what are anti-hyperlipidemic agents? Now, anti-hypercholesterolemic agents act by either production of lipoproteins or by their removal from the blood. Now, there are certain classes of anti-hyperlipidemic agents. The first class is HMG CoA reductase inhibitors. Now, there are again two classes of HMG CoA reductase inhibitors, which is natural and synthetic. The natural class contains the lovastatin, simvastatin, and pravastatin, and synthetic class contains the fluvastatin and atorvastatin. There is another class which is made up of miscellaneous agents. The miscellaneous agent includes the ezetimibe and clofebrate. There are certain other classes of anti-hyperlipidemic agents, which includes the fibric acid derivative. The fibric acid derivative contains the drug clofebrate and fenofibrate. There are bile acid sequestrant, which contains the drug cholestyramine and cholestyramine. There are another class which is inhibition of cholestyramine. which includes the drug probucol, and there are a last class which is pyridine derivative. The pyridine derivative contains the nicotinic acid. Now, the today's main topic is HMG CoA inhibitors. We'll see the HMG CoA inhibitors. So, what exactly are HMG CoA inhibitors? The HMG CoA inhibitors, these are the inhibitors of the enzyme HMG CoA, which catalyze the reaction, which includes the HMG CoA is converted into the mevalonate. So inhibit the enzyme HMG CoA reductase, which converts the HMG CoA to the mevalonic acid. So further, this mevalonic acid is converted into the cholesterol in our body. So to decrease the amount of cholesterol in our body, HMG CoA inhibitors are used. So this is the basic reaction, which includes this HMG CoA in presence of HMG CoA reductase is converted into the mevalonate. These are inhibited by the statins. The statins which are HMG CoA inhibitors. So this is the rate limiting catalyst in irreversible conversion. So as we have seen earlier, there are two classes of statins, that is HMG CoA inhibitors. The first one is natural statins, which contains the lovastatin, simvastatin, and pravastatin. And the last one, synthetic statin, contains the fluvastatin and atorvastatin. These are the structures of lovastatin, simvastatin, and atorvastatin. The structure contains the lactone ring, that is a closed lactone ring, which is spaced by the ethylene group from the bicyclic ring. So simvastatin and lovastatin are differ by the methylene group at the second position of butanoic acid. So this is the butane, and at second position in lovastatin there is only presence of single methyl group, and simvastatin there is presence of two methyl group. So moving forward, we will see the SAR of HMG CoA reductase inhibitors. So this is the basic structure of HMG CoA inhibitors. The structure contains the three parts. The lactone ring. The first one, we will see this lactone ring. As we can see, this is the lactone ring. The second one is ethylene bridge. This is the ethylene bridge which acts as a spacer in between the lactone ring and the bicyclic ring A. This is the bicyclic ring. So we'll see the in detail SAR of the lactone ring and every structure. We see the first one is the lactone ring. The 3,5-dihydroxycarboxylate is essential for the inhibitory activity. That is 3 and 5. If you can see my cursor, the 3-hydroxyl and 5-hydroxyl group is essential for the inhibitory activity of the drug. So if 3 or 5-hydroxyl group is absent, there will be no presence of inhibitory action by the drug. So compounds containing the lactone are product requiring in vivo hydrolysis. That is, if this ring structure, lactone ring structure is closed, then it will need to be hydrolysis in the body. After hydrolysis, the drug can show the inhibitory action. The stereochemistry of the substituent is less crucial to the activity. Now we'll see the SR of ethylene bridge. Altering the distance between the C5 and the bicyclic ring. If you can see, this is C5 and the bicyclic ring, as we have written here the ring. The altering the distance between C5 and the ring, it will diminish the activity. That is, if we replace this ethyl group with methyl, propyl, or any other group, it will diminish the activity of inhibition of that drug. Now, introduction of double bond in between this ethyl group, in between, that is C6 and C7, it will either increase or it will either decrease the activity. We will see if ethyl group is present. If ethyl group the ethyl group provides the optimal activity for the compounds containing ring A and some heterocyclic compounds, that is atorvastatin, which contains the pyrrole ring. As we can see, this is the structure of atorvastatin, and this is the ring structure, and this is the lactone ring. If you can see my cursor, there is no presence of double bond in between C5, C6 and C7. Hence, these are the optimal activity shown by the ethyl group in the atorvastatin. So we'll see if ethylene group is present, then it is optimal for the compounds with other rings such as indole, quinoline, pyrimidine ring, such as the drugs are fluvastatin, pitvastatin, and rosuvastatin. That is, if we can see fluvastatin, which contains the indole ring in its structure, there is presence of double bond in between C6 and C7. So this is the optimal condition for this drug. Now, this is rosuvastatin, which contains pyrimidine ring in this structure, and it contains again the C6 and C7 double bond in between them, which is the optimal condition for them. Now, bicyclic ring A. This is the bicyclic ring A present in HMG CoA inhibitors. The ring is essential for anchoring the compound to the enzyme active site. The replacement of cyclohexane ring resulted in the 10,000-fold decrease in activity. That is, if we replace this ring structure with cyclohexane, it will diminish the activity, or it will decrease the activity by 10,000 folds. Now, conversion of the ester to an ether result in decrease in activity. That is, if we can see this is the ester group, if we replace it with ether group, it will decrease the activity. Now, the second next one is methyl at R2 position. It will increase the activity. If you can see this R, this is the R2 position. If we replace this R2 position with methyl group, it will increase the activity. And next one is beta hydroxyl group at R1 position, enhance the hydrophobicity and may provide some cellular specificity. This is the R1 position. Here we have replaced with methyl group, but we have written here that is with beta hydroxyl group, it will increase the hydrophobicity of that compound. So this is what my seminar was. If you have any question, you can ask me.
So, really, it was a nice presentation. Content was good, and PowerPoint I could see was truly it was a great content with best presentation. I just can see. There are certain questions are there from the viewers. So let me put in front of you those who are.
Hello, sir. Myself, Sahil Mahajan, and I just want to ask, can you just explain the structure of lipoproteins?
Yes, I will explain the lipoprotein. I'll again share my screen and I'll show the structure of lipoprotein and I'll explain you. Hello Sahil, if you can see the structure of lipoprotein, it is made up of two units, that is central core unit and the outer monolayer unit. The central core unit, as you can see, is made up of triglyceride and the cholesterol esters, which is surrounded by the monolayer of phospholipids, free cholesterol. If you can see, these are the cholesterol, free cholesterol, and these are embedded in the monolayer. Also, the monolayer also contains the apoproteins. So this is the basic structure of lipoproteins.
Okay, sir. Thank
I
you, sir.
hope you are clear with your doubt.
Yes, sir. Sure.
Thank you.
Hello, myself Akanksha Susguru, and I have a question for you. Can you just tell me what is the relationship between the HMG CoA reductase inhibitors and cholesterol?
Okay, I'll tell the difference. Good question it is. So HMG CoA reductase inhibitors and the cholesterol. First of all, we will see what is HMG CoA inhibitors, reductase inhibitors. So what exactly HMG CoA reductase does? It converts the HMG CoA into the mevalonate. So this reaction is catalyzed by the HMG CoA reductase, and this further the mevalonate is converted into the cholesterol in our body, and this cholesterol is available for the use in our body. So I'll say when the cholesterol levels in our body are elevated or sufficient in amount, then that time this enzyme gets suppressed because we don't need the cholesterol furthermore. So I'll say the maximum amount of cholesterol in our body is present in LDL, that is low density lipoproteins. I'll tell that there are two sources of cholesterol for our body. The first one is dietary supplement, and the second one is de novo synthesis. As we have seen earlier, and we have studied in second year, the de novo synthesis from which the cholesterol is get made up or synthesized in our body. So I'll tell, when we take the dietary supplement of cholesterol, it get absorbed from the intestine. When it get absorbed from the intestine, it is transported to the liver and other body organs of the body, and that time the and the on the other hand, the LDL is also having the site for the cholesterol. So cholesterol get attached to the LDL and transported to the peripheral part of the body. Uh, when when this cholesterol got to the peripheral part of our body, it get attached to the LDL receptor. There are LDL receptor present in the peripheral parts. When LDL complex with LDL receptor, it get endocytosis and get degraded. By the degradation of this complex, they form the free cholesterol, which is available for our body. So by this, the cholesterol amount get increase in our body. So coming towards your question, what exactly HMG CoA reductase inhibitors does? HMG CoA reductase inhibitors increase the amount of LDL receptors in the liver. So what exactly happens? Increase in the number of LDL receptor in liver, it will increase the binding of this complex in the liver, and there will be more degradation in the liver. So there will be less cholesterol available in the body. On the other hand, HMG CoA reductase inhibitors inhibit the de novo synthesis, and hence there will be no further production and synthesis of cholesterol in our body, and the cholesterol get reduced in our body. So this is the basically relation between both of them. I hope you are completed with your doubt.
Yes, sure. Thank you, sir.
Hello. My question for you is there a way to distinguish between lovastatin, simvastatin, and atorvastatin as far as the structure is concerned?
Okay, I'll show my structures, and from them I will tell you. So basically, these are, if you can see the structures, these are the structures of lovastatin, simvastatin, and atorvastatin. The lovastatin contains both of them. Lovastatin and simvastatin contains the butanoic acid at which are attached to the bicyclic ring, and at the second position of lovastatin there is presence of only methyl group, and in the simvastatin there is presence of two methyl group at the second position. So the potency and the priority of simvastatin get increased. So this is the basic difference between the lovastatin and simvastatin. I hope you are satisfied with my answer.
Thank you.
Hello, sir. I just have one more question for you. What
Okay.
are the types of hyperlipidemia?
Okay, so there are basically 6 types of hyperlipidemia. If you see, there are 6 types, which includes type 1, type 2. The type 2 also contains type 2A and type 2B, and their fourth type is type 3, the fifth type is type 4, and the sixth type is type 5. So what exactly happens in these all types? The first one is type 1, which in which there is decrease in the lipoprotein lipase enzyme. So what exactly lipoprotein lipase enzyme does? It decreases the triglycerides levels in body. So decrease in triglycerides, hydrolysis of triglycerides, it will decrease the cholesterol levels in our body and triglyceride levels in our body. So the next type is type 2A. In the type 2A, there is increase or elevation in the amount of LDL in our body, and the triglyceride amount remains the same. Then the third type is type 2B, in which there is increase in the VLDL, that is very low density lipoprotein levels are get decreased along with the LDL levels in our body. The type 4 is very rare, and it includes the broadband of beta lipoproteins. And the type 5 is type 4, and the type 6 is type 5, in which there is increase in the levels of VLDL and chylomyelin. So I hope you are
Yes, sir.
hello.
Yes,
I
sir.
hope
Thank you.
you give your answer.
I have another question for you. Is there a natural
Okay.
replacement available for statins?
Yes, we can replace the statins with fibrates. There are synthetic fibrates too and natural fibrates too. As we can see, there are certain sources of fibrates which are apple, orange, and you can see the green tea is another source of fibrates. Then niacin is also there. We can replace statin with niacin too. These are the other substances from which you can get the activity rather than statins.
Okay, thank you.
Thank you.
Okay, I have one more question for you. Can you tell
Okay.
me that how exactly ezetimibe work?
So ezetimibe is from the miscellaneous class of agents. As we can see, ezetimibe inhibits the absorption of cholesterol from the intestine. What exactly ezetimibe does? The ezetimibe blocks the protein, that is niamin, like wait, I'll tell. Niamin peak like C1. This is the protein which get inhibited by ezetimibe, and from this ezetimibe is working. That it inhibits the absorption of cholesterol, and by this the cholesterol levels get decreased in our body. So
Okay, thank you.
okay.
That's all about the queries now. I really appreciate the way you have answered and resolved the queries of all the viewers. Now it's time to stop here. But before that, Miss Sakshi will share her views. Over to you, Sakshi.
Yes, thank you, sir. Thank you, Rahul, for delivering a seminar on anti-hyperlipidemic agents. It was truly helpful to understand the basic concepts of medicinal chemistry through your seminar. The explanation you gave helped to consolidate facts about the topic, and the Q&A session made the seminar even more enriching and interesting. So thank you for the presentation.
Uh, Thank you. I'm thankful to Mr. Chajar sir too to give me the opportunity to deliver the seminar on this topic and guiding me in this topic. So thank you, sir.